Hello everyone and welcome to class. Today we will be talking about geometry, which is actually our third week topic for SS1, geometry. Now geometry is quite wide, but our focus will be on triangles and polygons. Triangles and polygons, and we'll be dealing with some general theorems on triangles and polygons. Now, very quickly, I'll be splitting this class into two videos. In the first part, I'll be bringing to your awareness these theorems, and in the second class, we'll be solving questions. Is that alright? Okay, very quickly, let's start with the first law. The first law that says that what? The sum of angles in a triangle is what? 180 degrees. So if you have a triangle like this with three interior angles, A, B and C, A plus B plus C is actually equals to what? 180 degrees. The second theorem states that what? The exterior angle of a triangle is equal to the sum of the opposite interior angles. Now if you have this A, B, C, D, what this theorem actually means is that what? A plus B plus C. Sorry. A plus B is actually equals to what? D. A plus B is actually equals to what? D. The sum of the exterior angle of a triangle is equal to the what? Sorry, the exterior angle of a triangle is equal to the sum of the what? Opposite interior angles A and B. Now the third one, the sum of the interior angles of any n-sided convex polygon is n minus 2 times what? 180 degrees. When we say convex, I mean this. Now this is what you call your what? Your convex. But when you have a polygon that looks like this, this is called what? Re-entrant polygon. Now this one, whether regular or irregular, now first of all, take note of the fact that what? As long as it's convex, the sum of the interior angles is equal to what? N minus 2 times what? 180 times 180. Okay. There's also another law for the exterior angles of a convex polygon, and that one states that what? The sum of exterior angles of any n-sided convex polygon is 4 right angles. What do you mean by 4 right angles? 360 degrees. What is a right angle? A right angle is what? 90 degrees. So we have 4 right angles, which is what? 360. That's 4 times 90. 4 times 90. Now, very quickly, we will be dealing with what? Our types of triangles and how we can denote them. sometimes they might not tell you the type of triangle, but from the signs, the symbols used in the drawing of the triangles, you can denote what type of triangle it is. Now here we will not be talking about the size of the angles per se. We'll be focusing more on the types of triangles according to their length, according to the length of their sides. And so for that we have 3 types. We have your equilateral triangle, always denoted like this. All angles are what? Equal. And if the sum of angles in a triangle is 180, if they are divided equally, you have what? 60, 60, 60. 60 degrees. This is your what? Equilateral what? Triangle. Then you have your isosceles. Now there is another theorem, which is our 5th theorem. That 5th theorem says that what? The base angles of an isosceles triangle are equal. When we say the base angles, it doesn't have to always be down here. Your isosceles triangle can have this form. Now this means that these 2 sides are equal, and these are the 2 base angles that we are talking about here now. So these 2 angles here will be equal. Are you following me? Here the 2 angles here are equal, but when it's bent like this and you have the symbol like this, it's still the same thing. It will not be these 2 angles here now, it will be what? These 2 angles here. These 2 angles are now the base angle when the triangle is being what? Flipped over. Do take notes. So you have your what? Isosceles triangle. And then you have your scalene, which most times is not indicated. Most times you don't see symbols like this. You just see that it's just there. Are you getting me now? And so if you have your scalene triangle, there is no law per se that applies to this, except probably this one when you are solving questions related to what? Scalene triangle. Then you also have your right angled triangle. Right angled what? Triangle. Now how do we know right angled triangle? Regardless of the posture, a right angled triangle always has this symbol. It has one of its angles as what? 90 degrees. It means that what? These other 2 angles, the sum of these 2 other angles will also be equal to another 90 degrees. Then in total, their sum will be what? 180. And if you have an angle placed here, say angle A, this particular location is called opposite related to this angle, and this particular side is called adjacent related to this particular angle. This side, which is the longest side of your right angle triangle, is known as the what? Hypotenuse. So do take note of all this that I have just explained. Before we deal with parallelograms, let's talk a bit about congruent triangles. Now, congruent triangles are triangles that actually have the same size, and the same shape. For example, if you have a triangle looking like this, and this is 30 degrees, for example, and this is your right angle triangle, and you have another one looking like this. And this place is 30 degrees. Are they congruent? Yes, especially if they have the same size, the same measurements. They are congruent. So whether they are having the same position, that is where this one is standing, this one is falling, or this one is bent toward this direction, facing this direction, it doesn't really matter. What is more important is that what they both have the same size and shape, irregardless of the what of the positioning. Now let's talk about parallelograms very quickly. Let's talk about parallelograms. Now, parallelograms have the following properties. Opposite sides are equal. In a parallelogram, opposite angles are also what? Equal. So you have a parallelogram that looking like this. Opposite sides are equal. These two sides are equal, these two sides are what? Equal. Opposite angles are also what? Equal. This is A, this is B, this is C, this is D. It means that A actually is equals to C and B is equals to what? D. And also, their diagonals, they have what? Two diagonals. One is what? One is longer than the other, B? Yes. And the diagonals bisect each other. Very important. It means wherever these diagonals meet is actually the center of this parallelogram. Actually the center of the what? Parallelogram. Now, if you don't know, do take notes. Your square is actually a parallelogram and your rectangle is also what? A parallelogram. So these laws that are written here apply to your square and your rectangle. Of course, your square has extra laws added to it. For example, in your square, all sides are what? Equal and all angles are what? Equal, unlike your normal parallelogram. But take note, your square is actually a parallelogram and your rectangle is also a parallelogram. Now, very quickly, looking at equal intercepts. Equal intercepts. If three or more parallel lines cut off equal intercepts on a transversal, it means that they also cut off equal intercepts on any transversal. I will break it down. Now, these are parallel lines. For example, these are parallel lines. Now, parallel lines are always related by arrows. Now, if this line is parallel to this line, they have the same number of arrows. Sometimes it might be double arrow signs. Are you following me now? Okay. Any line that crosses two parallel lines like this is called a what? A transverse line. Now, if these are actually parallel lines, the length from here to here is actually the same thing as from here to here. If these three lines are actually parallel to each other, if you put another transverse line like this, are you following now? This side is actually equal to what? This side. And that is all that there is about what? Transverse line. Let's look at another diagram so we get a better understanding. Now, as long as these three are what? Are parallel. This line from here to here is equal to from here to here. So if they give you from here to here, for example, as 6, let's say x, y, z, and they say they give you x, y to be what? 6 centimeter. Let's say she find what? X, z. X, z will be what? This is 6, this is 6. So from here to here will be what? 12 centimeter. It's that simple. It's actually that simple. Same thing also applies. This is also another transverse line to this parallel line. You can actually what? Extend this line like this. This is a parallel line, right? And this is actually a what? Transverse line. And so from here to here is the same thing as from here to what? To here. And the same rule also what? Applies to that.